DNA information. But first of all, I'm going to give a word to my colleague, software developer, Art&Science, the guy who made this beautiful application which recrypts DNA information into the music language. So without further ado, ladies and gentlemen, Art&Science.
Hello, in this video I want to demonstrate a fast to nodes, a little command line application for converting the FASTA files to SuperCollider code. So FASTA files is a text format for storing genetic data, and you can find a lot of these FASTA files into NCBI database in the web. So let's start. At first, the CL-FASTA nodes package should be saved to QuickLisp folder. So this is actually a general folder for all Common Lisp projects. Here is a file structure, and we have a build folder. So from the last version, you can build a binary, and let's run it. So use the help command to see available commands and let load a file. I already saved one. Oh, sorry, try again. Okay, file loaded. Let's check file info. So we can just put some sequence to the screen. Let's try to use some random numbers for the start and end of sequence. Okay, the result makes some sense. And let's save this in SuperCollider, because now it's only format you actually can export. Lillipond is broken from the last release. Okay, and quit. So I will check this file in Emacs editor. So let's start SuperCollider. Let's boot a SuperCollider server. And yes, here it is. Our file, our generated SuperCollider code. So I actually prefer to use P1 Arctic class. Sorry. But pbind is more general, and I think the generated code should use pbind because it's suitable in more cases than P1 Arctic. So I already prepare some fancy FM scene definition. So let's stretch durations a little bit, because it can be quite fast. So yeah, and this psequence class is also kind of a bug in a code generation. So actually this psequence with ones, it's just one. Okay. And let's listen. this little video was helpful for you, and maybe see you later. So yeah, check the GitHub repository of projects, and bye.
Thank you very much, Arseny. After all those iterations, you will get a SCD file, which is mainly used in a supercollider, and it will probably looks like this. So, as we can see, here is a simple pattern in the pbind. It is a very fancy thing in a supercollider, but we will not gonna get too much into this because you will always can find a very good tutorials on YouTube about supercollider. Just to keep things faster and smoother, I will show you the whole way I did to make a musical composition using a DNA sequence. Well, so you will get this amount of information, which consists of 3 points. First of all, its amplitude, and it represented by one number because actually we don't have much information from a DNA sequence. And here it is a special number which represents the highest amount of amplitude you can have for one single note in the supercollider. After that is dur or durance, which is represents durance for them every note, and degree, scale degree for every note. Well, first thing you will probably want to do this is to put into your DAW. So you can do this like this. Here we have a not very big amount of code lines. First code lines actually represents a MIDI flow to your DAW, and we will not stop on this. I want just to specify one thing here. As far as we don't have a very interesting amplitude sequence, so I put a randomizer here which chooses amplitude for every single note between these numbers, the lowest and the highest. After all those things, you will hear something like this. As you can hear, I already made some producing features with that, just to make it sound more fancy. So that's basically it, but it's not that interesting. Okay, let's stop it for a moment. As far as you can see, it does not sound that interesting, but for the first time I worked with that, pretty much stopped on that and used only this amount of information just to make music for a solo part. So, but as you can see here, we have a chords, and I did it in a supercollider as well, and we will briefly look on how to make it. Here is another, actually this is the same code I used for that project. Here we have another pbind, which is works a little bit slower, and it have a special function for it. It brings more note to degree which were generated from a pine tree sequence, and it brings -6, -12, and -3 for each node, and builds a whole chord for our composition. And it sounds like this. Sorry. And so on. So that's pretty much it. As far as you understand, I'm not a programmist, I'm just a musician who tries to use some generative approaches to his music, and especially for that project I wanted to keep things traditional in structure, and You can always find much more fancier ways to use the DNA information in Super Collider to make much more interesting music, and I'll be very happy to hear your creation based on that technology. So, and that is not the end. Next, I'll give a word to my colleagues, which will show you some fresh ideas on how to choose organisms for your creation. They have chosen 7 organisms in spatial order, and the next good thing is that I took those organisms and recrypted DNA information into the MIDI files so you can freely use it. We will bring a special link to it. Freely use it into your creation, change it, improvise, experiment with that. And you can find an MP3 audio files there as well to listen to it without DAW. If you're interested in music we were talking about before, you can always find it on my SoundCloud or anywhere else. Now I'll give a word to my colleagues.
Hello everyone, we are Veronika Prizova and Maria Mashenska. We want to share with you an alternative possibility for your inspiration. This is DNA information that can be used as a new source method. This transformation provides a great background for creativity and generative art. After receiving data on the DNA of any organism, you as a musician, artist, can interpret it. For example, we selected 7 organisms that are participants in the oak biosynthesis. All of them are in close connection with each other, are inseparable, and belong to 3 main groups: producers, consumers, and decomposers. Why exactly oak and its biosynthesis accomplices? Because they live among us. And of course, this is an opportunity to purchase a data source from nature for your artworks. So there are producers: common oak, lily of the valley; consumers: redwood ant, maybuck; decomposers: sap, azotobacter, oak moss. To make it clarify, biosynthesis is a set of living organisms that coexist for a long time in a certain space and represent a certain ecological unity. Now then, we chose organisms that are part of the biosynthesis because we thought about the topic of universal codependency. Sometimes we do not pay attention to the minor details of the puzzle that are interconnected, but nature does not allow for neglect and sees the whole picture in its unity. So look around. Maybe this little but significant world is hidden somewhere nearby, for instance, on your window as a home plant. It's all in our memory. Recall your sounds.
Hello everyone, my name is Evgeny Klopotov and today I want to show you how to use our new MIDI file in MASP and convert it into different frequencies to create, for example, oscillators or something like that. And this very short lesson will be for beginners, so let's start. To work with our MIDI file, we need to create a sec operator. Max allows us to save a lot of time by using already written code. Let's click right mouse button on sec operator and open sec help. Unlock this patch. And I want to select all these parts which I will use. Now I can delete this sec. Okay. I want to delete all parts which I won't use. Delay, record, print, and write. Okay, there are three types of objects. Now we can see here. It's bang, it's like a button. Message, start, stop, read. You can see this border, round border, and operators. Okay, let's modify this page. I want to create an instrument to change speed. Now we can set only 512 milliseconds speed, but I want to change it like this. Start with $1, and now I will press I button, it calls integer, and I will connect it here. Okay, now we can slow speed. Okay, stop it please. Let's make an order, and here, nice. Okay. Now I want to delete the MIDI out operator and create MIDI parse. And MIDI to frequency M to F operator, connect here to the left output. Okay, cool. And we can check what is the frequency right now. We can hear it right now because we didn't connect. We need to switch on. Hey. I hope it will work and you will hear. For example, let's use triangle oscillator. You can use triangle help to create something more complicated, but this is not necessary right now. Vibe gain is our volume control. And channel 1 here, and channel 2 here. We can change the size and connect this MIDI to frequency and triangle oscillator. Okay, let's check. we can use not only triangle, but also we can use rectangle, cycle, and so this tilde, of course. This tilde means this operator works with sounds, and now you can see these wires and these wires and these wires, they are different. Okay, we can create a G gate to switch it really fast. Let's go to our inspector. All number of outputs. Let it be 4. Okay. And now I need to connect this. This one, and this one. Okay. Now we need to connect let's try it. Very important moment. Now I saw blinking of our bank. Here it means bands and our right outlet when sequence comes to the end. It means we can create a loop. We need to connect this output and this input. Watch chord, lovely, and let's try again. That's all for today. Thank you for your attention and have a good day. Bye.